Good morning. My name is Navjot Singh Gill, and I am an application engineer with PLM Solutions. I want to welcome you to PLM Lunch Bytes series. These sessions are designed to briefly explore capabilities within Solid Edge that are often overlooked. Today's session will be on Simulation Express. If you have any questions regarding today's session, please write them down and send them via email. We have a lot of you on the line with us today, so you'll be in listen-only mode, so that we don't get any feedback from speakerphones, etc. Once again, today's topic is simulation. So before we get into more details about the workflow inside Simulation Express, some of the terms which I'll be using today will be stress and modal analysis. So what is a stress? When a body is subjected to an applied load, a stress state is caused inside the body. And when we're talking about load could be a force, a pressure, temperature, etc., etc. So the next one is the modal analysis. What is the modal analysis? Modal analysis, we get by doing modal analysis, we get parameters such as natural frequencies and also principal mode shapes. So with the help of modal analysis, we can solve distinct deformation shapes that a vibrating system will assume at each of its preferred oscillating frequencies. So all these frequencies which we will get, and we'll make sure that none of the other components inside the assembly have that frequency, because if these frequencies match, then there's going to be resonance effect, and that's why we have to avoid that effect. That's why we do this modal analysis. Now, one thing to be very careful is there is no wrong answer in FEA. So only wrong questions. So if the user can learn how to pose a question correctly, they can get good answers. So what are these right questions? So by right questions, I mean boundary conditions. So boundary conditions are loads and your constraint. The load can be your moment of inertia, your force, pressure, temperature, acceleration, etc. And your constraint would be typically, you will constrain your faces. You can it can be your planar faces or cylindrical faces. So by doing that, you resist the translational and rotational deformation induced by the load. So one thing to note here is, depending upon what type of mesh you generate, for example, if you have a model, a 3D model, and you do a tetrahedral mesh, you generate tetrahedral mesh. So users should be aware that a tetrahedral element, have only 3 degrees of freedom. And if you do a plate element, like for typically sheet metal application, then the elements which will be formed on that surface, there will be a plate element. So those plate elements will have 6 degrees of freedom, 3 translational and 3 rotational. Now, as far as product offerings are concerned, there are 3 product offerings: the Simulation Express, full-blown simulation, and FEMAP. Starting off with FEMAP. So as the problem complexity increases, like for more complicated analysis type, we use FEMAP. It gives you a broad range of analysis type, such as buckling, dynamic, basically nonlinear analysis type, like heat transfer, etc., etc. And one thing to note here is FEMAP is a solver-independent product. So all the 3 offering here, they use NX Nastran solver at the bottom, you can see, but FEMAP is solver-independent. So if you have your company investment on some other solver, you can always pick and choose between different any other solver you can use for doing analysis. So let's come to this other product, that's simulation. So the only difference between Express and simulation is in terms of analysis type. You can do analysis on assemblies with the help of full-blown simulation, and also it gives you a wide range of load types, and also it gives you very flexible set of tools to use to modify your mesh. So if you want to change the element size on a particular edge or a particular face, all these tools are available inside of simulation. And as far as study is concerned, you can do buckling inside of simulation, while Simulation Express you can only do static and modal. no buckling. And also, Simulation Express is a part-based analysis tool. You won't be able to analyze your assemblies. So the one last thing is study type. I'm sorry. Is a study type. So with Express, you can only do a single study, but instead of in comparison simulation, you can have multiple studies. For example, I want to do a study on the 1,000-pound load and also 1,500 and 2,000. So all these 3 studies can be done inside simulation, and we can just create different studies in the same environment. While in Simulation Express, since we can have only one study, so we have to get the results and save the results, and then we have to create another case for study number 2 rather than doing everything at once. All right, Simulation Express. As far as the license is concerned, there are 3 license offerings, such as Design and Drafting, Solid Edge Classic, and Solid Edge Premium. So Design and Drafting doesn't have any of the analysis tool. Simulation Express is a free tool available for users who have a Solid Edge Classic license. And users who are running on Solid Edge Premium license, they get free access to simulation, full-blown simulation. So in order to access Simulation Express, what you do is you just go into Tools, and there's a group, Environment group here, and inside that there's a Simulation Express tab. And you'll notice here that I'm inside a pod. I'm inside a pod, so I can reference the background assembly as far as the directional loads are concerned. So before starting the process of creating analysis, we will just look into some of the mesh settings. So you'll notice this dialog box. There's a small bar here, and you can change the size of mesh. So you can change from coarse to fine, and this all depends upon. Usually what I do is, for first run for design validation, I just keep it coarse. So what it has a bigger mesh, so it gives me quick result, and I can just get the numbers, and then subsequent cases I just get the mesh finer. I just move this slider bar towards right, and then get the results. So the reason why I do that is because you can compare these results. So now, if the more finer the mesh, the more accurate the results are. FEA is it's an approximation technique. So whenever I change the mesh resolution and get my results, I just make sure that there's no much difference between 2 cases, and that would be my that's what I try to achieve. Now, the first step here, as we already talked about, once we selected the mesh, then what we do is we select the body of the model we want to do analysis on, and then the important step here is defining what type of analysis I want to do. So I have only 2 options. Either I can do stress or modal. And then comes the material definition stage. And here what you do is you define what type of material you want to use for that model. So if you have defined your material inside Solid Edge, you don't have to define it again. So it automatically links to that material. So, but you will have this list here, and you all might be knowing we can always add material, and this list is coming from your material table inside of Solid Edge. You can create custom materials if you're following ASTM standard for any custom material specification. Make sure you add that material in, and when you add, put all the values for Young's modulus, Poisson ratio, and everything, and so that material specification we can use it inside our analysis. The third step is load definition. Now here here we're just specifying your boundary condition and defining load. So you have 2 options for load. Either you can apply pressure or you can apply force. So what you do is just specify what you want, enter the number, hit next, and then you can specify the phase. Now at this point, I would like to bring this idea of simplification. Now usually what people do is, like, they have a model, they design model, and they have a separate model for doing FEA. But with Simulation Express, what you can do is, as it's very well integrated inside your Solid Edge, what you can do is you can use your simplified models inside Simulation Express. So in order to do simplification, you go to Tools, hit Simplify, and then you can use all your delete face, delete hole tools in order to get rid of some of the geometry which you want to just eliminate. So in this case, you'll see that this is my design body, and this is my simplified model, which I'm going to do analysis on. Now, once you define the load, you can select the phase where you want to apply the load, and hit Next, and then the next step, we define the direction. Now, in this case, what I've done is I've just selected I've selected an edge from the background assembly in order to define the direction. And then what I've done is there are options to flip the direction. So once you've selected the direction, you can always flip it. And you can use all your background components in order to define the direction of the force. Once you define direction, the next step is constraints. Now here what you do is you select faces you want to constrain. So by constraining, you are just preventing the translational and rotational degree of freedom based on what type of mesh you have selected. So after that, it's we just hit run, and it's going to use NASPEN solver in order to get our results. So results will be displayed this form. You will have stress analysis, stress, area of high stress, and also areas of higher displacement, etc., etc. Now, in this slide, it's kind of sum up the entire process. So what we do is we start off with the defining material, defining the mesh, and then as we go from left to right, we define the loads, we define constraints, and then we define what type of result. Now, this bar is basically results. Once we get into results, what type of result display we want on the screen. We can have a stress display, or we can have a displacement display, or factor of safety. And once you have your results, you can also play animations, and also you can save the animations as an AVI file, and also you can generate an HTML report. So these are just a screenshot of some of the formats for result: stress format, and this one is a displacement format. You'll notice the face here that highlights in red. So this face would be displaced the most once we apply the load. And then here's a factor of safety. You can also turn on and off contours. In order to, you can also turn off the deformation. All right. Now this is very important. Sheet metal analysis. In sheet metal, what we do is we have a concept of mid-surface in Simulation Express. So mid-surface, what it does, it automatically creates a surface. And once we have this mid-surface, what you can do is you can create a mesh on this mid-surface, and those that mesh would be will constitute of all the plate elements. So all these plate elements will help us in getting all the 6 degrees of freedoms, like 3 rotation and 3 translation. All right. So that finishes off first half of the presentation. Next, I'm going to demonstrate you all these different type of analysis types with the help of the assembly. Now, here I have this heavy equipment assembly, and I'm going to focus on the framework of this equipment. So there's a lot of stress in the hitch area. So the way it's connected is these two portions connected with this part, and we're going to run analysis on this part because it's going to carry all the load. So I have a couple of display configurations saved, and I can just quickly select one display configuration which has this subassembly. Now, in order to do analysis, like we are in Simulation Express, we'll be using that. So what I'll do is I'll just edit inside the part, and I'll activate this part in order, because I'm going to use that part for putting it at directional. So inside Tool, you'll notice there is a group, Environment group. I can select Simulation, but I've also had that Simulation tool inside my radial menu. So I can just select Simulation here, and then start. Now, before I do that, what I want to do here is I want to simplify the model, because I have some holes which I want to remove in order to get my mesh refined. So what I will do is I'll just hide background components so that I can just concentrate on that part. So what I can do here is I can just select the simplify model command, and then I have option to delete all the holes. Now, if I select this option here, I can select all these holes individually, or I can select all the holes by operator. So what this does is I can select whatever I want to select. Say, for example, I can select all the hole feature, or I want to select all the cylindrical or conical faces. So in this case, I'm going to select this hole feature, and you'll notice that I get an alert. So what this tells me is by default, the value is 1/4 inch. So there's no hole less than 1/4 inch. That's why it gives me this alert. So what I'll do is I'll bump up this value. You'll notice that all the holes, they get selected. And now I can just simplify the model. I can delete all the holes. Similarly, I can delete the faces. All I have to do is just select delete face command, select these faces here. So just in 2 steps, I was able to simplify the model. Now I can go back to, I can just turn on my background assembly, and now I'll run my simulation express. As you know, first step is defining body. We have already defined the body, and now here also we can specify what type of analysis we want to do. Here in this case, we're going to do stress analysis. I've already defined material for this part, but if not, you can always select material from the material table. So we've defined the material, we defined the body we want to select for analysis. Now we can add load. So with the help of add load, I can define what type of load I have, like say force or pressure. So I can just select the force option here. I'm going to put 1,000 pound of load, and it's going to concentrate on this face, the circular face. I can hit next. Now the next step is a direction. So for direction purpose, I want to use the background assembly. So I'm going to select this edge, and that will define the direction of the force. I'm sorry. And then you can flip the direction if you want to. And then that defines step 1, that is our load definition. The second step in the boundary condition is constrain. So for constraining, what I'm going to do is select this face on the back side and in here. So that will constrain the model and also solve it. So now it's going to use Nastran solver and give us quick results. Now once we have results, so what we can do is you'll notice that there are some additional commands which are available, and what you can do, you can just play animation if you want to, and you can also, we have capabilities to save the animation as a .avi file. So all you have to do is just pick the right option here, .avi file. You can save it. And also you can, right now result defaults to stress. You can also change it to displacement. That will show you the face which will be displaced the most. So the one that highlights as red. And also on the right hand side, you will see this vertical bar. What it does, it tells you the displacement values here. At this point, what you can do is, if you want to create a small report of this analysis, you can use HTML report generation tab, and you can give it say like hitch for stress analysis. And then you can enter all the data, put an introduction, conclusion, create report. So what it does, it takes some screenshots of our study, and also it put all the data which we have defined in boundary condition state and also material definition stage into a HTML file. So you'll notice that it creates, it's using 1 Mises stress for doing analysis, and it tells you minimum and maximum stress. Also, it creates some screenshots. You can make them bigger. And so you can save this HTML and send it to your coworker or your customer. So that was a stress analysis. Now, the next thing which I'm going to do is do a different type of analysis, that is modal analysis. For that, I'll just activate this display configuration. So what we're going to do is we have this exhaust pipe here, and it's sticking out of, and it's hooked to the motor. So the motor is driving this heavy equipment, and it's going to stand up external forces such as vibrations from the motor. So what we're going to do is we're going to analyze the part and calculate first 4 common frequencies. So we know the motor, it can generate 3000 RPM. So it goes to close to around 50 hertz of frequency. So we want to make sure our pod is nowhere close to that frequency, because if this exhaust pipe, which is going to be hooked to a motor, it has the same frequency, then there will be a resonance, and we want to avoid that situation. So in order to do that, I'll just edit inside the pod, and what I will do is just select Simulation Express. In this case, instead of stress analysis, I'm going to select modal analysis, hit accept. Now, there's no force. We're not going to apply any force in modal analysis. All we have to do is just constrain a face. So for constraining, we'll just select this face at the end, and that's all we need to do as far as modal analysis is concerned. So what it will give me is give me 4 frequencies. So as you can see that the motor frequency which we got from the catalog is around 50, and this one also has 50. So I want to avoid this situation. So what I'm going to do is I'm going to make some changes in the model and then rerun the analysis. So for that, I'm going to use my dynamic edit tool and just change this model from 1000 to 600. So now I'll go back to Simulation Express. You will notice that it gives me a message that this model has been modified. So, and we need to rerun the analysis. If we hit yes, it's going to rerun the analysis and going to update the results. So now the frequency level is just twice what we got last time, and it doesn't cover the range of 50. So it's like twice. So that's what we wanted. So by doing this, by making changes, now we avoided that resonance change, resonance effect, which was potentially it would have damaged the port. So now what we can do is we can go back to our assembly. Now, the third thing which we're gonna talk about today is something called doing analysis on a sheet metal part. So it's a little bit different. So what I'm going to do is select the display configuration. I'm going to edit inside this board, and now I'm also going to activate this one, because I'm going to use this background part for defining directions. So now, since I'm inside sheet metal environment, if I try to run Simulation Express, you'll notice that I get this small alert. So what it tells me is, that there is no mid-surface. So mid-surface is an automatic surface generation tool which is available inside your sheet metal environment. And what you can do is you can select this this tab, and then just by highlighting the face, you can generate a mid-surface. So I can hide the design body, and that will show you this surface geometry here. So once we have this surface, what we can do is, now if I go back to Simulation Express, it will accept our body, because it finds that mid-surface, and now I can select this surface as my body, and now I've already defined the material before. Now in this case, I can add the load. Again, I'm going to use a pressure of 100 pounds and select this face. And for directions, I'm going to use this background component. I can flip it down, and it finished. So we defined the load. The next step is a little bit different than what we do inside modeling, part modeling. Instead of constraining a face, what we're going to do is we're going to constrain an edge. In this case, I'm going to constrain this edge, which is going to be connected to the frame component. So I can hit accept, and that will start the solver. And as you can see, we got results here. And you'll notice that we have plate elements. It automatically creates Simulation Express automatically creates plate element, and this is the area of high stress concentration. So what you can do is, if you want to hide this display of edge, you can use your Solid Edge tool. You can hide the display, and now it is a little bit more clear. You can see how this stress is being developed inside this part. So this would be just my test 1, and then my test 2, which I can always do is just bump up the mesh size, like make it more finer and get stress results and do comparison, and I can use those results for my design validation process. So that's all as I have as far as the demonstration is concerned. Now we have classes coming up month of December and January, and if you need more details about the classes, you can always visit our website. And also, Here's our contact information. One thing I would like to mention is I posted this link for simulation lunch bite. What you can do is you can go through this link, and then you will have a 30 minutes presentation on simulation, which is one step ahead of Simulation Express, and there we do analysis on assemblies, etc. That's all I have as far as this Simulation Express session is concerned. Thank you very much for your time.